just to put issues into perspective. And I also hope that by now, if you checked your emails, you should have a copy of my book, Metals in Past Societies. I made a PDF available to everybody who participated in this course. So if you don't have a copy of that, just either let me know or let Mede know. But otherwise, most of the things that I was talking about, they are in. I took them from that book. If you are interested in the subject, I think in June or thereabout, I should have another one coming. This time published by MIT Press. So the one that you have was published by Springer. So these are some of the things that I talked about yesterday. Of course, that's mbira, or a thumb piano. Again, just emphasizing the chronological differences between the regions. So this was meant to emphasize not these dates of 1000 to 1700, 1700, 1800. So the key question is, can you have iron smelting before copper smelting, given that the technology associated with iron smelting is a little bit more complex. Complex in the sense that the temperatures, the required temperatures must be higher, at least within the region of 1,200 degrees Celsius. For copper, it's more or less the maybe melting point for copper is what, 1084. So slightly above that, you could smelt copper, but for iron, the temperatures were a little bit higher, 1,200 and so on. And remember that it was a solid state reduction, because the melting temperatures for iron are a little bit higher, within the region of 1,500 plus degrees. Then this is just to emphasize the routes of dispersal, but of course, given those earlier dates that I showed, there are some people who are now believing that this area, and perhaps somewhere here, there are independent centers for iron production. Southern Africa is very, very, very late, and that's associated with the Bantu migrations. So one of the questions that I was going to ask you, particularly those of us who have got experience with metallurgical engineering, is it possible to start smelting iron without knowing how to smelt copper, or without having a technology that require manipulation of higher temperatures, such as glass and such as maybe a glazing of ceramics? That's something that also requires high temperature. Is it possible? Any volunteers? It could be. Okay, we can talk about that towards the end. So this is just a map which summarizes. So the concentration of these dots here also reflects where most of the research has been done. The reason why this area has got a number of dots is that Roger Summers published a book in 1969 called Pre-Colonial Mining in Rhodesia, Ancient Mining in Rhodesia. Actually, that's the title. And he was looking at gold mines as well as copper mines. So as a result of that, that's why there is quite a bit of information. I mentioned that when you are in sub-Saharan Africa, you don't have the benefit of written records, such as when you are in Egypt, Aksum, or other places. So we don't benefit from some of those literary sources that tells us exactly how the technology was, how the recipes for producing metal. So what we do is we just borrow techniques from earth and engineering sciences. So this is a photomicrograph of an iron smelting slag from Mapungubwe, and these are different phases in simplistic terms. They tell different types of information. This is magnetite. This lighter shade is more wustite, iron oxide, and these phases here are iron silicates, and that's the olivine ferrite. So the different, the estimates or the volume of these phases can enable us to estimate, for example, the efficiency of the reduction process and so on. So we do study these microstructures quite a lot. We also supplement them with data from X-ray fluorescence, the SEM, and other techniques. So this is perhaps a much clearer images, and this is all blocky ferrite. And as you can see, there is less in terms of these lighter phases, which means that perhaps on the basis of this, the furnace that produced this slag was more reducing than this one. So that's an example of how we would build arguments about the efficiency of reduction. So I hope this photograph is clearly visible from the back, but it's a reproduction from Alfred Depper's 1668 book. So Depper was a Dutch traveler that came to Africa and produced a number of interesting drawings, some which were redrawn from memory when he was back in the Netherlands. You might have observed, particularly in that DVD in Agina, that there was some area where you could see some elephants and it looked like a map and so on. So that is Depper's book. And there is a reason behind that. They said that when Depper sailed from the Netherlands to Africa, he was hoping to see these big cities. So in each instance, when he didn't see a city, he would draw an elephant, a lion, or something like that. Whether that's true or not is something else. But in this image here, Alfred Depper is illustrating a technique of mining that is known as underwater dredging. So what they could do is that you can dive, such as what this one is doing. You dive into a river which has got gold-rich sand, and then you scoop it up, and then the people who there are some of these guys who would then pan using the technique of density separation. It is a well-established technique. This is in modern-day Ghana. But the Portuguese also discussed the practice of the same mining technique in northern Zimbabwe along the Mazowe River. But in the Mazowe River, they could also strap a piece of rock at the back so that they could dive even deeper. So just different techniques of mining. So these are Roger Summers' illustrations. I talked a little bit about mining. So how were they practicing it? You can see, so these are skeletons, people who were trapped when an incline, a mine shaft collapsed. So safety in the mine, an issue today, an issue in the past. And then sometimes you can have a great deal of luck in terms of preservation. This is wood, and that's a bucket. So the wood, the miners could attach a rope here and there, and then that was used to hoist the ore to the surface. So natural draft furnaces, this is Togo. I mentioned Phil de Baroche's work in the area around Bassa, and I also got these photographs from him. Scale of production, these are the slag mounds. that I said in terms of volume estimates, DeBarros thinks that some of them could have at least 160,000 tons. These we saw the other day, just a variability in furnace types. These two twin butterfly-shaped furnaces, these are from the Mugeni Valley in KZN. So it is, some of the reconstructions suggest that these were operated by at least two people. So you connect the bellow here, and then one here, another one there, another one there, and then you can pump in a rhythm. I haven't seen any ethnographic example of that. This is just an archaeological reconstruction. This is a furnace from the middle Senegal river in West Africa. So shaft furnaces, when they collapse, that is what you are left with. And as archaeologists, this is some of the evidence that we use. Distribution of furnace types is quite a very messy situation. Bellows, they hardly preserve in the archaeological record. These are known as concertina bellows. In this picture was taken by Phil DeBarros in Burkina Faso. So in terms of volume, these are more efficient than a number of bellows, such as the big bellows or those pot bellows. These ones are quite efficient. There's a study that was done that measured the flow of air from these bellows, and it demonstrated that they were pretty effective. Distribution of bellow types across Africa. Here, it doesn't mean that nothing was happening. It simply reflects that we don't know much about those areas. So I mentioned throwing knives. So these are some of the throwing knives. This one was made by the Azande in Central Africa. And this one is more, this comes from Ethiopia. So quite amazing in the way in which they were made. So in terms of, I mentioned that the Mafa of Cameroon could produce cast iron, could forge weld steel to soft iron. So in some cases, you could find maybe this part is steel and this one is soft iron. So reflecting that people understood the properties of metal. This we have seen the mbira. So these are the gongs, the iron gongs that I was talking about. That these ones are from Great Zimbabwe, and most of the examples that we know today are from north of the Zambezi, right up to the Ivory Coast. So you could hit some very nice notes. And in terms of percussion, you could actually combine it nicely with this type of mbira. At least the good thing is that nowadays the mbira is now electrical. So you can play it just like you would do the piano. So gold, I mentioned that gold was panned. Sometimes they would have little bits and pieces of gold, the gold dust. These porcupine quills, so that's where the gold could be stored. This is a soapstone mold. So molten gold could be poured into this to produce these types of prills, beads, if we may call them. And this could be worked to produce different types of objects. Manipulation of non-ferrous metals. So these are cross-shaped ingots, copper. They were used mostly for copper. These are what are known as Katanga crosses. And these small vessels were used, crucibles, which were used for, in some cases, smelting, melting, and but these ones look more like molds, which were used to produce small batons of gold. So these are part of infrastructure which was used to produce metals. This earring we saw, medallion we saw, these ones. So coming to Southern Africa, these are the famous Mapungubwe golden rhino, as well as this bowl. The thickness of this gold sheet is perhaps 1 millimeter. So that's very thin gold foil. How these objects were made, it is believed that perhaps a wooden dummy was made, and then the foil was then attached to it, which is why we see these texts and those walls. And the belief is that perhaps the wood has now decayed. So that's why we are just left with that outer shell, which is 1 millimeter thin. So that's Mapungubwe and some of the crown jewels. I mentioned, I showed that mold here. So this is what, these are the outcome. If you pour copper into that mold, you come up with those Katanga crosses. This is an object that is quite popular, or that was quite popular in northern South Africa. These are what are known as the Masuku copper ingots. They were mainly produced by the Lemba and the Venda people. So they do vary in terms of design. So they say that sometimes if you count the number of these studs, that also correlated to the weight as well as to the value. Some have got a core of sand, others are solid metal. So it just depends. Copper, sometimes you can excavate burials and find and realize that people often were buried with a lot of metal objects. So this is a burial from Danangombe. Just this is one of the long bones of the leg. As you can see from here to there, it's all a lot of copper bangles and bracelets. So the key question then is that could you realistically work with this metal in real life, or these things were attached when somebody was dead? We don't have an answer for that. It's just all guesses and guesses and guesses. But it's quite a lot, and it's substantial. This picture is this is on display in one of the museums in Bulawayo. I mentioned Igbo Uku. This is the famous roped object. The original size is, I think, it's 30 centimeters. So what an amazing masterpiece in terms of a lost wax casting. This is another object from the same archaeological site. You can see these designs. So that's why I was saying that this tradition dating from AD 800 to 1200 perhaps is a precursor of those Benin bronzes, more of the same. From Igbo Uku, particularly that snail, is quite amazing. Benin bronzes, these are actually brasses. Some of these were attached to the walls and then the like. These are some of the well-known images of these Benin bronzes. So when I came to UCT, my predecessor actually gave me photographs of this one, which are nicely framed. So if you come to my office, you will see 3 or 4 of these, which I got as a very generous gift from Nick van der Merwe. I hope this map is clear from the back, but the intention is just to show the connections that would have taken place across the Sahara and then in Central Africa. It is possible that we could have lines and arrows in this area, but again, in the absence of research, we can't say much. And also, if we, from the beginning of the Atlantic slave trade, we also see technologies going that way, going to Brazil, going to Cuba, and the other places. One of the projects that I'm working on at the moment is looking at technology transfer between the Mbuntu communities in Angola and some of the communities in Brazil. What is amazing is that there are some people, descendants of the former slaves, who still speak fluent Bundu as if they were in Angola. So what we are interested in is exploring some of those technological exchanges. So like technology transfer from Central Africa, from Angola to Brazil, and hopefully we will extend this work to Cuba. Right, that was just emphasizing some of the points from yesterday's lecture. What I'm going to be doing today is focusing on a very interesting aspect of metallurgy, which is basically the human factor, the human side. So technology, yes, it has practical purposes in life, but it also has a human side, a cultural side associated with it. So what I will do is that I will talk about the cultural beliefs, the metaphors associated with metallurgy in different regions of Africa, and then try to summarize, emphasize some of the important points, and perhaps make one or two points relating to cross-regional comparisons. This is an iron smelting furnace, still standing, probably made in the late 19th century. It's in eastern Zimbabwe, Nyanga National Park, and it is decorated with these features that we see on human beings. I will talk about the significance. This is an iconic photograph which was taken by Legros in 1888. So this is a picture of Venda smelters. This place is just probably 3 kilometers to the east of modern-day Elam, and this furnace is still standing. So there is some interesting cultural issues happening there. And then this is a shaft, traditional mine shaft at Rooiberg. So Rooiberg just after Bela Bela on the way to Tabazimbi. There are some galleries and shafts. If you go there today, you will see these, and it's amazing. We did a documentary in one of them. It's quite nice. So, one of the good starting points when discussing the issue of the anthropology of technology is that pyrotechnology in general in most African communities is a gendered practice. So there are some technologies that are associated with men. There are others that are also associated with women. So, for example, in the ethnographic record, we realized that pottery making, like these photographs from Botswana, these pots, they are the domain of women, and men are not allowed anywhere near where pots are being produced or where they are being fired. So taboos mandated that men had to stay away. So the same applies to metallurgy at a level of generalizations. Metallurgy, smelting was seen as the domain of men, and women were forbidden from pressings where metals were worked. So at this generalist level, that is when where most of the early anthropologists, so late Mungo Park and that generation, as well as David Livingstone, if you are in Southern Africa. So they made some very interesting observations that dichotomized technology along gender lines. This is what women did, this is what men could do, but with no overlaps. But nevertheless, some of these early observers, for example, Leo Frobenius and others, they were interested in the unusual, in the exotic, as well as in the what looked like the bizarre. So the outcome of that is some of the travelers' reports of the late 19th and early 20th century, they're actually very interesting to read. But one of the things that we see is that from those reports, for example, the missionary Buster, who was based in modern-day Venda, he made quite some interesting observations about iron smelting. And he noted that iron smelting was replete with symbolism and sexual metaphors. So the process of iron production, iron smelting, was metaphorically associated with human copulation, human reproduction, as well as the process of giving birth. So Buster made those comments, Ricard, and there are many other people. So the other thing is that iron smelting was associated with the use of medicines to neutralize the power of malevolent forces, evil forces. And this is archaeologically recoverable because when you excavate furnace bases, in some cases you can find that there are clay pots that were planted inside the furnace. And Nick van der Merwe, when he was excavating at Palaborwa, he excavated a furnace base and then got a clay pot which had some human digit fingers. So his interpretation was that it was used to make muti, perhaps to make the smelt successful or to stave off the evil influences. And then there were also some rituals and taboos that smelters had to observe. So amongst the FIPA of Tanzania, the smelters were required to practice sexual abstinence with their real wives a night before smelting. If they violated this taboo, then the smelt would not have been successful. So this symbolism extended to even the language. The furnace is described as a wife. And then, so the whole process is full of sexual symbolism. And the 2 years, those blowpipes that supply air into the furnace, they are also known by the same names as the name of the male reproductive organ and so on. There is a very interesting iron smelting furnace that was recorded by Father F.O. Bernhard in eastern Zimbabwe, that was decorated with a picture of a woman who was given birth. So, but if you read in the book, I have a reproduction of that image. It's a pity that here I don't have it. But again, the idea is to emphasize the fact that human reproduction and metallurgy, they were sort of a symbolic synonyms. So the child from human birth was also the same as the iron bloom. It was also treated as a child. So in some cases, there are reports that iron smelting could not be performed inside villages because of associated taboos, and also perhaps so that the men could not be tempted by their wives, I don't know. But iron smelting furnaces, in most cases, or rather, let me say in some cases, they are located in secluded places away from public gaze. So the interpretation, if we are to use some sociology or anthropology, is that just as human reproduction is done in private, then smelting was also done in private. But of course, there are some contextual differences. So coming back to the issue of medicines and beliefs in, witchcraft and so on, the missionary Buster made a very interesting comment, particularly with respect to Venda iron smelting. He says that the Venda use human flesh in iron smelting, and if they run out of supply, they scavenge the dead. So if you read the Buster's 1879 report, that's what he says. But the most interesting thing is that in terms of the people who engage with the politics of knowledge production, this statement is often cited as one of those cases in which early European, missionaries, travelers, they exaggerated certain cultural practices amongst the local groups. But if you are an archaeologist, such as Nick van der Merwe, you excavate a clay pot at the base of a furnace, and you realize that the bones that are there are human digits. Is Buster lying? Is he exaggerating? I don't know. We can make up our mind, but it's one of those interesting issues. I mentioned the fact that metal production is full of fertility symbolism. This ridge here, ethnographically, it's a waist belt that was worn by women to enhance their fertility. So that's something that you would find somewhere around here. And you could also see some of the features, for example, these molded features. So the anatomy of this furnace is meant to represent the female body. And that emphasizes the fact that iron smelting was metaphorically associated with human reproduction. So what we also see is that there are so many similarities between the iron smelting furnace as well as the clay pots. And this is a diagram from David Collett's 1993 paper. And the furnace here was recorded by Theodore Bent in 1892, somewhere near Great Zimbabwe. And what David Collett here is illustrating is that the anatomical features that you find on the female body are the same as the ones that you see on the furnace. I leave other features to your imagination to interpret. The other thing is that we also see clay pots, which in the ethnography are the domain. They are owned by women. To borrow a phrase from Ashwaubenon, they are a woman's weapon. The designs that one sees here are the same as what one would find on female items of dress. So what this slide is showing us is the fact that some of these pyrotechnologies and associated beliefs, they are pervaded more widely. But the theme of the female body and the furnace being metaphorically the same is quite a very strong one. And that's a feature that one can find across most of sub-Saharan Africa. So some reports from the late 19th century in what is now modern-day Tanzania, particularly relating to FIPA ironworking, they say that when the smelters finished building the furnaces, they would decorate them with powder, apply makeup in a way that one would welcome the bride into those communities. So that emphasizes the same aspect. In some cases where there was the organization of people involved with technologies into castes, such as the areas around modern-day Mali, smelters and potters could marry each other, but they could not marry outside. So that caste system, but in Southern Africa, we don't have much evidence of that. In the late 1990s, Andrew Reid and Fiona McLean did an iron smelting reconstruction in modern-day Tanzania. So what happened is that they had the local people reconstruct the whole process from the start, more or less the same as what we saw in that video in Guinea. So this is a picture from their World Archaeology paper. In this, they are demonstrating that ritual and medicines, they played an important role in smelting. So what this photograph is showing is that as part of the rituals, the smelters and the ritual specialists, they had to push some of the earth into the furnace to close off the furnace, the pit that contained the medicine. So that was also meant to ensure that the evil forces were neutralized. In the same paper, the Andrew Reed and Fiona actually makes it clear that some of these smelters, during the process of smelting, they were actually making some of the gestures that a man would make when being involved in the process of sexual intercourse. So again, emphasizing the entangled nature of some of these beliefs in particularly witchcraft, the similarity in the process of human reproduction and the process of iron smelting, to the extent that, as we can see in these photographs, the gestures that people would do are the same as what they would do in another activity. This is one of the images from Tanzania. So this is the base of a furnace. This is all ceramic, and after excavation, they found this pot. So that's what I meant by, in some cases, we could find clay pots underneath. And unfortunately, because some of the medicines were organic, they would have decayed. But nevertheless, this is quite a common feature of traditional iron smelting in most of sub-Saharan Africa. Mike Rollins and J.P. Vanier, they also documented a similar practice in modern day Cameroon. So quite pervasive, quite widespread, but of course this we don't see in places such as Egypt. The similarity is just that religion in Egypt was also involved, as we saw in the involvement of the gods and so on, but not as much as this symbolism or this idea of medicines. So this is a schematic representation from one of Bertram Mapunde's papers. Again, the medicines here. So the furnace charge would then be on top, just to emphasize the same fact that the belief in medicine was quite strong. These are illustrations from Nick van der Merwe's work, where he found different types of furnaces. He says that this is more the Palaboro type, and this is more the Venda type. But a common denominator in these cases is the presence of this hole that was dug, and that is where the medicines were inserted by the smelters. Whether that resulted in successful smelting or not is debatable, but that's something which they did. The other challenge is that yesterday I mentioned the fact that in terms of metal recovery, typical iron smelting slags would have between 50 and in some cases 50 to 70 weight% iron oxide. So what happens in a case of a failed smelt? where people could not produce any iron but produced a slag. Sometimes the composition is just the same. So it is very difficult to detect failed smelts archaeologically. In some cases, it is because you would find a lot of metal rings of metal that did not have a chance to fuse into a bloom, and then the slag would not have drained. In that case, yes, you can perhaps speculate that this is a failed smelt, but that is a big archaeological challenge. And for that reason, we don't know whether this belief in, if, for example, medicines were not used, whether smelts would be successful or not. But using the knowledge from modern chemistry and our understanding of the incandescence of hot gas molecules, we would know that perhaps these had no practical function. It's just as long as one had the balance right in terms of the raw materials, maintaining the fuel to ore ratio, and then also consistently supplying the air, then you could smelt. But I must admit that in 4 attempts to reproduce this traditional smelting, I haven't succeeded yet in producing any usable bloom. Whether it's because I'm not doing any rituals or not is something else. Again, more of the same picture, just that's from Nick van der Merwe's paper again. So this is again the triangular furnace, and these are the dome shapes. So you would find this medicine pit at the center of the furnace. I mentioned the fact that women are associated with furnaces, and what is interesting is that from a position of gender, I have this slide just to try and provoke you. I promise that I'm not always a troublemaker. Yes, women have got their position in technologies such as smelting, as well as in technologies such as pottery making and so on. But what we often see in archaeological studies is that there isn't much of a role for women. So their role is mostly restricted to auxiliary services, such as fetching water, carrying firewood, cooking. We don't see any women who are smelting. We don't see any women who are smithing. The reason being that it is believed that these were gendered as male, and women were not allowed. In fact, some of the rituals, some of the taboos dictated that women who were undergoing their monthly period were not allowed either to touch the ore, they were not allowed near the mines, neither were they allowed during the smelting, and that's something that came out of that video. So the most interesting thing is that what do women archaeologists say about that process? And particularly the fact that it was mostly men who were studying these technologies. So Eugenia Herbert, formerly of MIT, she wrote a book which is entitled Iron, Gender, and Transformation, published by the Indiana University Press. In that book, she is arguing that transformation is at the heart of heat-mediated processes such as iron smelting. So you transform the ore into usable metal through the application of heat. And she also says that, you know, like what everybody else says, the idea of the pervasive nature of sexual symbolism, the omnipresence of rituals as well as beliefs. But what is also surprising is the fact that the contribution of women to smelting is also reduced to very few pages. So maybe, given that in modern day South Africa we are all about hashtag this, hashtag that, maybe we could say, because she has been working in a male-dominated environment, then maybe patriarchy breeds patriarchy. But the most interesting thing is that even the language that is used to say that if women are collecting the ore, then it is an auxiliary service. It's not really smelting. Can you smelt without ore or without charcoal? Or is it that, as we saw in that video, you needed to understand the qualities of the charcoal that came from different tree species? So that counts as knowledge. But yeah, it's something that is debatable, and at the moment, the reason why I'm interested in this is that I'm co-editing a book on gender in African technologies, which will be published by Oxford University Press, hopefully next year. But if we go into the archive and think about what different people are saying, there is somebody called Hatton who wrote that women could also pump bellows during smelting, and that in some cases a woman could actually smelt with her husband. And then some furnaces were located inside villages, others were also in secluded places, but the end result is that all furnaces produced iron. These are reproductions from Theodore Bent's book, and I also have them in one of my chapters in the book that I emailed to you. I talked about those features that we see on furnaces. This is a granary, and what do you see? Those C-cetrization marks, and then you also see what might be female breasts. So this is a drum, and similar features, and that is a furnace. Similar features. So what I argue is that if fertility symbolism also extended to granaries and extended to drums and basically everywhere where people interacted and mingled, why should it determine the location of smelting? Does it make sense that you say, well, I'm locating my furnace away because it's associated with symbolism, and then you have a granary which is like this in the middle of the of the homestead, or you have a drum like that in the homestead? Food for thought. But the key thing is that space is shared and everything is shared between the genders. So Nick van der Merwe did some interesting ethnographic study in Malawi. And during the process, he said to his colleagues, the local colleagues that he was working with, because he had noticed that there were some women who were part of the process. And his reading of the anthropology and what he was also taught at university was that women were not allowed anywhere near African iron smelting. So Nick van der Merwe asked one of the senior guys and said, why are women present here when we are supposed to be only men smelting? So the guy said to him, are you going to be doing the cooking? So the moral of the story is that yes, women participated. In some cases, they pumped the bellows and so on, but it's just that the way perhaps we were writing the past, the way we were writing the anthropology is to some extent patriarchal. It does not fully acknowledge the contribution of women. One of my favorite examples of women participating in the process of metalworking comes from the modern-day Democratic Republic of Congo, the Katanga region, what is now Lubumbashi. De Hemtine, who was a Belgian traveler, he observed a very powerful female leader who was seated on a stool, supervising a group of, according to De Hemtine, hundreds of male miners. So that's the contribution of Women for You. And then in central Zimbabwe, Njanja women could smelt, they could mine ore, and the examples, the list of examples can go on and on. But in all processes, rituals were also adhered to, and women could mine, they could also